Let's say we have to sort an array of unsorted elements. MergeSort operates by dividing the array in two and repeating this process on each subarray until we're left with two single-element subarrays. We know that one element for sure means the array is sorted. Once we have a sorted array, MergeSort does comparison on each element, combining the arrays into one sorted result array. This process is repeated recursively until the original array is sorted. 7 is greater than 3, so the result array starts with 3 and then 7. As I said, we repeat this process recursively. 4 is greater than 3. We proceed by joining the two sorted arrays. Onto the right side, breaking it down until we have two single element subarrays. Make the comparison and merge them together. The time complexity for MergeSort is n log n. The first n comes from the merge operation when we look at each n element for a comparison. Log n comes from splitting the array in half repeatedly. This is a logarithmic operation. After the first split, we have two halves, and then 4/4, and so on, until we reach n segments. This is log n. Now I'll do a side-by-side implementation in JavaScript. We'll start by defining the MergeSort function. MergeSort takes in the array, the low index of that array, and also the high index of that array. If the low index is less than the high index, we're going to split the array in half, but we need to know the middle. So the middle is going to be the floor value of a simple calculation. Low plus high divided by 2. Once we have the middle, we can recursively call MergeSort array low. For the left subarray, we're going to pass in middle. Middle in this case is 3 because low plus high, 0 plus 7 divided by 2 is 3.5, but math.floor gives us 3. This recursive call, 0, we're passing in the array, 0, and middle. The next recursive call is going to give us the right side of the array. So we'll pass in array. In this case, the low is going to be middle plus 1. And we'll pass in the high index as well. What's happening here is we check, is 0 less than 7? Is 0 less than 7? Yes. So the middle is going to be 3. And then MergeSort, this line here breaks down the left side of the array, and the next line breaks down the right side of the array. So we get two subarrays. The next recursive call, we call MergeSort again, one more time, but this time middle passes the high index. So is 0 less than 3? Right? Is 0 less than 3? Yes, it is. So the middle is now going to be 1. 0 plus 3 divided by 2, math.floor gives us 1. Here we're passing in the value of 2. Middle plus 1 is 2 in this case. This index here. High is 3. This index here. So these two lines now give us these two subarrays. We recursively do this until we have 0 and 0. At that point, we call merge. Merge takes in the array, the low index, the middle index, and also the high index. Once these two functions result in two single element subarrays, it's time to merge them together. We can implement merge down here. Merge takes in the array, low, middle, and high. Now we have to define our two subarrays. So the left array, we'll just call it left side. The right side is the same. We need to loop through each subarray to make a comparison because we're checking for n elements. So in order to loop through each side, we need to know the length of each subarray. So we'll define the left length as follows. The left length is going to be middle minus low plus 1, because the low could be 0. The right length is going to be high minus middle. Once we have the length of the two subarrays, we can then populate them. We can do this by implementing a simple for loop. Let I is 0, while I is less than the left length. We'll increment I, and we'll just populate the left side. So left side, I, equals array low plus I. Same thing for the right side. We'll use j this time. J is 0, while j is less than right length. Increment j. Right side j is going to be array. We'll do middle plus 1 plus j because we want to start at the middle for the right side. Once we've populated the two subarrays, we can then make the comparison. But first we have to redeclare our pointers. I is 0, j is 0, and we're going to make a third pointer here that's going to represent the low index for the resulting sorted array. We'll call that k. K is going to be low. Now we can make the comparison. While I is less than the left length and j is less than the right length, if left side I is less than or equal to right side j, we will populate the resulted sorted array. Array k is going to be left side I. Whenever we make a change, we have to increment the pointer associated. So we'll increment I in this case. Else, array k will just equal the right side. Array k equals right side j. We'll increment j, and k is always changing, so we'll increment k down here. That's essentially it. The only thing left to do is to copy any remaining elements from each subarray to the resulting sorted array. While I is less than the left length, array k equals left side I. I increments and k increments. We'll do one more for the right side. While j is less than right length, array k equals right side j. Increment j and k, and that is it. Now let's define a sample array. The sample array will be let's call MergeSort on the sample array. Array low is going to be 0, and the high index is just going to be the array length minus 1, because we know that JavaScript arrays start at index 0. We'll log the array. As you can see, 1, 2, 3, 4, 4, 5, 6, 7, 8. The resulting sorted array. This was MergeSort. If you have any questions, feel free to comment. Thanks for watching.